exactly what Google started doing a couple of years back in a partnership together with us. What they do is that they receive our forecasts 24-hour ahead, and then they are starting to schedule the computations to make sure they happen at the optimal time. And now they're even doing it in space as well, which means that if the wind is not blowing, for example, in Denmark, but it is blowing in, for example, Ireland, they will take that computation job and shift it to a different location. From an infrastructural point of view, this is a massive feat because you need to have the data available, you need to change all the requirements. This is a pretty big change in the way you operate suddenly your assets. In order to make this happen, we need to produce these forecasts, and I just wanted to give you a sense of how complicated this actually is. I showed you before these small arrows on the map. This means that if you want to know how clean the electricity is in Denmark, you need to look at how clean the electricity is in the neighboring countries, because we import from them. They also import from somewhere else, to import from someone else, and you can even have a bit of a, a snake who would bite its tail. Like you can have some circle loop flows in the system. So we have to look at the whole interconnected grid in one go, and then make a prediction for the whole grid in order to be able to come to Google and tell them, look, this is the optimal time to run your computations. So there's a pretty big AI lift that we have to do in order to get there. And on the right side, I'm just illustratively showing you a report that we have that showcase our forecasting quality that are generated automatically. Whoops, this is a bit sensitive. There we go. These are some of the early results that Google showed on this particular initiative. What you can see in green is the forecast which we are providing of the carbon intensity. So basically how dirty the electricity would be per unit of electricity consumed. You have the blue curve, which is the non-optimized load shape of the data center. And you see here in orange the effect of responding to the carbon intensity signal and modulating the amount of jobs that are running on a data center by either pushing them over time. You can see on the right side here this interesting rebound effect. You're delaying as much as possible the jobs, and as soon as the electricity becomes clean again, bam, you have all the delayed jobs that are getting scheduled again because they are quite sensitive, so you get this rebound effect. And in this experiment, they did a dual cost optimization, so they looked at both, we want to minimize our emissions, and we want to minimize our costs. And so there's also electricity prices that are coming into play here, and luckily when the electricity is cleaner, it is often also cheaper. So there's no reason not to do it, basically.